In this video, we're going to talk about the last transformation known as a phase shift. So this is the horizontal shift that we've been sort of skipping for the time being. So you might see, so this would be a transformation of the sine graph. So you might see it written like that. Similarly, you could have the cosine graph, same idea. So there's an a times the trig function, so sine or cosine, of bx minus c plus a d on the outside. And then what you want to do to talk about the period and the phase shift is you actually want to factor out that b from the inside. So we're going to pull out the b, and then I just have x, but then instead of minus c, I'm going to have minus c over b. Okay, so what you want to imagine is if this b went back in, the b here and the b here would cancel out, and I would just get the minus c. So that's why it's c over b. So the c over b is called the phase shift. Okay, and this is the horizontal shift. Okay, so if you have it written like that, then the amplitude, say similar, like as it was before, is the absolute value of a. Okay, so it's always positive. The period is still the period of these graphs, so 2 pi, divided by the b value. Okay, the 4 subintervals that you're going to use is always the period divided by 4. So you want to split into 4 parts. So here that would be 2 pi over b divided by 4, which is actually 2 pi over 4b. Or I guess you could simplify that to pi over 2b if you want. Now the phase shift is c over b. The vertical shift, like we had before, is d. So again, c over b positive means that you're going to the right. C over b negative means that you're going to the left. Okay, so similarly, d positive means that you go up vertically. D negative means that you're going down. Okay, so what happens, so we're going to, again, try to do this all at once. So remember, without the phase shift, we already did that. So we had everything. So you find your period, you break your period into the 4 sub-intervals, so the 4 bits. And the d shifts your base. They call it the baseline here. I call it the middle of your graph. Okay, so you're going to go up d or down d, depending on if it's positive or negative. And that's your new middle. Okay, from there you go up absolute value of a, down absolute value a. That's where your peaks are, your peak and your valley, I guess, so the maxes and the mins. The phase shift is going to move it over. So what we're going to do is we're going to find the new start. Okay, that's going to be at c over b. And then we're going to go from c over b to c over b plus 2 pi over b. So that's the period. Okay, so we're going to go from the beginning, which is our phase shift amount, to 1 period away. Okay, and then we're going to split that interval into 4 bits. Okay, so that's the idea. So that from here to here is 1 period. And all of this is going to happen up here. Okay, so where the baseline is. So let's do an example. We're going to start with one that only has a phase shift. Okay, so here we are, so we're going to graph the graph of sine first. So let's do that. Maybe in green. So sine, remember, goes from 0 to 1, back to 0, down to -1, back to 0. Okay, so it looks like that. Oops, that's a bit. Okay, so it looks like that. It keeps going. So that is the graph of sine of x. Okay, let's put on some markers here. So this is pi by 2, this is pi, 3 pi by 2, 2 pi, negative pi by 2, negative pi, etc. Okay, now in blue, we're going to graph the graph of sine of x plus pi by 2. Okay, so when it says plus here, that's actually sine of x minus negative pi by 2. Okay, so remember, I'm just going to scroll up here. In our general form, it's minus c over b. Okay, so we want it to be minus. So that means that our c over b, okay, so b is 1 here. So that is negative pi by 2. Okay, so we're going pi by 2 to the left. Okay, so this point here, maybe I should go like that. This point here is going to move pi by 2 to the left. So it's actually going to be here. Similarly, this point is going to move pi by 2 to the left. So it's going to be here. Okay, and all of that is going to happen for all of these points. So they just are moving pi by 2 to the left. And I'm going to get a graph that looks like this. This is actually going to go through here. Okay, so this graph is sine of x plus pi by 2. Okay, now you might recognize this graph. It's actually cos of x. So if you shift pi by 2, the graph of sine or cosine, so you do the horizontal shift, you're going to end up with the other one. Okay, so the thing that we notice here is that sine of x plus pi by 2 is actually cos of x. Okay, which is kind of neat. Okay, depending on which way you shift. So there's a way that you can shift so that you get the other one. Okay, I'm going to leave 2 and 3 for you. I'm just going to do number 4 here, so it has everything going on. Okay, so I want to rewrite this so it's in the right form. Now it says 1 cycle, but I'm going to actually graph more than that. So I want to rewrite this. So the 2 stays out there, but then this is my b value, the 2 pi. So I need to take out the 2 pi, and then it's x plus 4 pi over 2 pi. Plus 1. So that's actually 2 cos of 2 pi x plus 2 plus 1, which is actually 2 cos of 2 pi x minus negative 2. Okay, so that means that my a value is 1. So that's my amplitude because it's positive. The b value is 2 pi, which means that my period is 2 pi over 2 pi. So my period here is actually 1. So that means my subintervals have length, my period over 4. So that's going to be 1 over 4. My phase shift, is negative 2, so that's 2 to the left. Okay, and my vertical shift is 1, so that's going to be up 1 unit. Okay, so that means, okay, so up 1, this is going to be my new middle or baseline. Okay, now I shift 2, and I want to break them into 4 bits. So I'm actually going to do, I'm going to put negative, so I'm going to go 2 to the left. I'm going to do it more than 1 unit though. So 1, 2, 3, 4, 1, 2, 3. So I'm going to put negative 2 here so that negative 1 is here, and then I have them into 4 parts. So this is negative 1 over 4, -1/2, -3/4, etc. Okay, this is negative 1.5, so that's 3/2, etc. Okay, because my lengths are 1/4, so I'm going to make each one step 1/4. Okay, so that's why I did that. So -2, so this is where my start is. Oops, because I phase shift to that point. So I'm doing the graph of cosine. Okay, this is my middle. My amplitude is 2. So I want to go from the middle. So cosine starts up. So I'm going to go up 2. So I'm going to have a point here. Okay, and then I split into 4 steps. Okay, so my period is length 1. So that means that from here to here, okay, is 1 cycle. Because that's my period length is 1. Okay, so notice that it has 4 bits. So this is -5/4. This is -7/4. So it has these 4 bits. Okay, so cosine it starts at the highest point, and then it goes down to the middle. Okay, so here's the middle. And then it goes to the lowest point, and the lowest point is going to be 2 away from the middle, the amplitude. Okay, so that's the lowest point, and then it comes back up to the middle, and then back up to the top. Okay, which is again 2 away, okay, from the middle. So 1 period of this graph is going to look like that. Okay, now if we do want more than 1 period, you just keep going. Okay, so here it's going to go down to the middle, down to the bottom, up to the middle, up to the top. So then it's going to come down again. Okay, and then it would just keep going. So here's going to be in the middle. Okay, here it would come down as well. So that would be our graph of this function. Okay, and 1 cycle has been outlined. Yeah, so the phase shift tells you where your start is. Okay, so that's all we're really adding to what we did before. Okay, so I left 2 examples for you to try. I will do those in a subsequent video. Okay, these are not, they're not really easy. Okay, so they take a bit of practice. But let's try something totally different. Okay, so here we want an equation that has these characteristics. So the amplitude is 3. Okay, so what that tells me, so the amplitude is 3, means that the absolute value of A should be 3, which means that A could be plus or minus 3. Okay, so we get to, we don't know, it could be either. Okay, now the period, I'm just going to switch colors here. So the period is pi by 2. So we want to find the B value. So that means that pi by 2 is equal to 2 pi over B. Okay, and I want to solve for B. So we multiply by B. So B times pi by 2 is 2 pi. And then if we divide by pi by 2, okay, that's 2 pi over 1 times 2 over pi. So the B value is actually going to be 4. So the pi's cancel out. So the reason I got that is because I want to flip the denominator and then multiply instead. Okay, so that's just a fraction rule. Okay, and then the phase shift being 2 means that C over B is 2. Okay, so you could, if you wanted, solve for C, but we could just start plugging it in now. Okay, so an equation that satisfies this, so I'm going to choose, so again, I mean, you get to pick. There's more than one correct answer here. I'm going to choose A equals 3. Okay, but I could choose -3 if I wanted. It would be the same. And it's a sine graph. Okay, so my A is 3, so it's going to be 3 times sine of the b value, which is 4, times x minus the phase shift, which is 2. And then it doesn't say any vertical shift. Okay, so then I would leave it like that. And if you wanted to expand in here, this is 4x minus 8. And then you can see here that your c value would be 8. Okay, if you want. And the d value is 0. But you could have also done that from here as well. If you plug in b equals 4, then you get c equals 8 right away. So that either of these would be a transformation that has all those properties. Okay, so it's an equation that has these characteristics. There's more than one answer. Okay, so you could have had a negative, you could have had a negative there if you wanted. But everything else actually is determined. Yeah, so that's how you can put it together to make an equation. So I knew it was sine because it told me it was a sine function. Okay, but then you can use all of these to figure out what your A, B, C, and D are.